All right, welcome back. This is homework number 3 for Fluid Mechanics Part D. The problem statement is asking to write an Excel VBA function for calculating the Darcy friction factor using the Churchill equation valid for both laminar and turbulent flow regimes. With this, calculate the pressure drop across a 100-meter long, 0.2 meter diameter pipe with a relative pipe roughness of 0.0001 when water flows through it at 0.1 meters cubed per second. Assuming electricity costs 15 cents per kilowatt hour, how much would it cost to operate a 100% efficient pump to maintain this flow for 2 hours? So there's many different Darcy friction factor equations out there, but we're going to be utilizing the Churchill equation seen below here because it is valid for all flow regimes. So I'm going to be utilizing a VBA function we created in class to help calculate our problem here. So if we open up our Excel, I will show you the macro here. So here is our Darcy function or Darcy friction equation, the Churchill equation in macro form, and we'll be utilizing this to solve our problem. So I've already put in the givens that were given in the problem, such as the pressure drop, length, or sorry, not the pressure drop, the length, diameter, pipe roughness, and flow rate. So those are what these numbers are. And let's start calculating our velocity here. So the velocity will be equal to, so our V is going to be equal to Q dot divided by 3.1416 multiplied by our d dot squared over 4. There we go. And our Reynolds number, we're going to be using our Darcy. It's rho VD over mu. So we get rho times V times D. We're going to put those in parentheses and divide it by mu over mu dot. And there's our Reynolds number. ED is going to be our roughness of the pipe, which was given. I just forgot to put it back in, so 0.001. Delta P is going to be our pressure drop. So we're going to calculate this in pascals. So it will be EC F of our Reynolds number and our pipe roughness times our length divided by our times our rho, our velocity squared over 2. And now we're going to convert that to atmospheres. So we're going to and divided by 101,325. And then we're going to convert that to PSI, which is equal to this number times 14.7, which is 5.1. Now we need power, so we're going to calculate our power in watts. Our pressure drop times our flow rate, and we're going to convert that into horsepower. Our power divided by 746. And the duration, remember, is 2 hours, but we're working in seconds, so this is going to be equal to 2 times 3600 to convert that into seconds. And finally, we're going to calculate our joules in order to calculate the cost, because the cost is related to the kilowatts per hour. So in this case, our joules is going to be equal to power times duration. And now we need to calculate that into kilowatts per hour. So to convert that, we're going to take this and divide it by 36. 1, 2, 3, 4, 5. And then we're going to multiply that number by 0.15 in order to get our cost. So this will be the cost of our problem.